Is my slide visible?
Yes, sir.
Okay, very good. Okay. So we are going to start. I hope that the recording has also been started. Okay, that's good. You can see it. Okay. So students, tomorrow you have the test, the class test, the first class test, and I hope that everybody has started preparing, and you are going to come prepared to the class. Um, does anybody have any question before we start formally today's lecture? Any question, anything that you would like to discuss with me? Okay, so let's get started. Today we are going to discuss a very important concept that basically governs the building of computer networks. It's a very fundamental thing, and we need to really understand it very well. So everybody please pay attention to whatever I say. Okay. So far we have understood what a computer network is, right? We know that when you have two or more computers connected to one another for the purpose of exchanging information, they form together an interconnected collection of different computing devices, which basically is called the computer network. So this is something that we know, and in the first one or two lectures, basically we have discussed a lot about the basics of networks, why networks are important. So this is just a recap of what a computer network is. Now, why do we need networks? Again, a brief recap, because it is very important to share different resources. For example, it is important to share data across between different computers, between two different individuals, between different organizations. It is required to share data, it is required to share software, it is also required to share certain computational hardware resources. So irrespective of where the different entities, for example, the users of the different computers are located, irrespective of that, computer networks can help you to get all these different users connected so that each user can get access to the resources that may not be physically co-located. The resources which are distantly located can be made available to the users. So resource sharing is a very important requirement for computer networks. Reliability is also very important, because so if you have computer networks, it is possible to have the data, the files, to be shared across and be stored in different multiple replicas in multiple computers. So reliability is very important. Sharing of the resources also reduces the cost. So reduced cost, excuse me, and and fast communication, implying that it is possible to share different data and information across quite speedily, right? So faster communication. So nowadays, so now, not nowadays, I mean it has been there for decades now, that we are able to send messages through emails, right? Messages through emails over computer networks. So that email basically, if this email was not there traditionally, or even now also, the other option is to send the messages through post, right? So computer network basically enables us to send emails which can be delivered almost instantly, instead of sending over post, which takes days, months, or sometimes years, right? So depending on how it is being sent. Okay, so So these are some of these different requirements for computer networks. Now another thing that I also wanted to recap once again is about the internet. We discussed a lot about it, but let us try to understand what the present internet looks like. So in the present internet, basically, what happens is you have clusters of different small networks, which may or may not be directly interconnected. Typically in the internet, what you have are small clusters, which indirectly are connected with each other, okay, and they form the overall internet. That means the internetwork of these small clusters of networks. So that's the internet that we all use, where we look for different types of information, through which we send emails, through which we are able to access files from one point to another, and so on. So when we are talking about these small clusters of networks, right, these will have to be connected with each other. So they are basically connected through something called the gateways. So these gateways basically help these small clusters to be connected to the internet backbone, and this way basically from any computer connected to this overall internet, we are able to connect to any other computer in the same internet, right? So that's the thing, right? Now, so these are certain things that are pretty obvious. You already know about it. In the first class, we talked about some of these things, but let us try to understand the complexity that we are going to get into. So far, in the so far basically from the beginning of the course till today, I have been talking about how to build small networks. So I started with discussions on connecting two computers directly. Maybe you can just wire them up, connect them through some cable directly. Cabling two computers is also, it also helps you to form a very simple computer network. You can extend this particular concept to interconnect multiple computers, but the complexities that you are going to get, that basically increases manifold depending on how you are going to connect them. So from connecting two computers to connecting multiple computers together in the same network, the computer networks basically gives you a lot of different features, lot of different functionalities, which if you adopt, you would be able to build up the computer network or the internet in a more scalable fashion. So keeping attributes of scalability, keeping attributes of efficiency, performance, etc. in mind, there are certain protocols that have been proposed. So this is where, so protocols also we have discussed before. Protocols are certain rules which the computers that are connected with each other that will have to follow in order to be able to talk to one another. So let us start with these two computers that I talked about earlier. In the first one or two lectures, we talked a lot about two computers connected with each other. We also talked about the different cabling mechanisms that are there. So if you have two different computers, connected directly with each other, I told you that there is a certain type of cable that can help you to do so. Can you tell me, if you remember, what that type of cable is called? What is it called? I told you in one of the introductory classes. So if you directly have to connect two computers, so one with the other, right? So there is a certain type of cable that can help you to do so. What is it called? So two similar devices have to be connected with each other. So so what is it called? What is the cable called?
Sir, crossover.
Very good. What is your name?
Jayant.
Jayant. Very good, Jayant. And so there is a sibling of the crossover cable. What is it called? It is different from crossover but looks very similar. What is it called? What is it? We all use it, right? we all use to connect to the internet. What is it called? The patch cable, right? So basically your crossover cable also looks very similar to the patch cable, right? So when I was covering the transmission medium, I told you it looks very similar, but basically the color coding that is used for wearing in the crossover and the patch cables, you know, these are different, right? So there is a certain way in which you can, you know, so visually if you look at a crossover cable, you will feel like, you know, it's it's just another patch cable, but actually it is not, right? So you know, so there is a certain way by which if you put both the ends of the cable together, you know, the layering pattern, sorry, the coloring pattern basically tells you whether it's a crossover cable or whether it is a regular patch cable, right? But anyways, so the point is that two computers connected with each other, we can do essentially anything that we want, starting from sending the bits to you know, running two applications collaborating with one another, right? So any kind of complexity we can have, but the moment we start adding computers to the same network, instead of two, we add another third computer to be connected, we have seen that we will get into a lot of different complexities. So those, for those complexities we have looked in at different types of schemes. So for example, there are schemes for you know, handling how the errors are going to be detected, how the errors are going to be controlled, how you know, the flow is going to be controlled, and so on and so forth. Many other different things are there, right? So many of which we have already studied, most of which we have already studied. So you see the complexity, due to the increase in the number of computers connected to the network, the complexity also increases. Now, if the complexity increases, in order to conquer this complexity, you need to take a logical approach. You need to take a logical approach in order to conquer this complexity. Now, this is where something called protocol layering basically comes into picture. This is where the protocol layering comes into picture. Protocol layering basically talks about that, you know, between two computers, you know, whether they are directly connected or you know, they are indirectly connected, we need to have these computers and the intermediate ones basically follow a certain set of rules, right? So these rules are many, many rules are there, right? So these rules have to be classified, they have to be categorized into certain groups. So this is where basically the layering concept comes into picture. Layering basically helps you to segregate, right, and group the different classes of you know, rules into different groups, right? So this is where this protocol layering comes into picture. Okay, so so think about this way. Think about this way, that you know, you and your neighbor, right? You are at your home and you have your neighbor, your neighboring house. You know, so you and your neighbor, you want to talk to each other, right? What do? Right? You go close to the fence, right? And both of you come out, and over the air interface you can talk to each other, right? So while you talk to each other, couple of things you have to make sure, you know, basically, you know, both of you can hear each other. So you just have to make sure that a couple of things are there, that you understand each other's language, you understand each other's vocabulary, right? And you basically you know, ensure that while one is speaking, the other basically refrains from speaking at the same time, right? And basically, you know, you also have to make sure that you know, it's a dialogue that goes on, not a monologue, meaning that, you know, so if somebody is speaking, the other party should listen, right? It should not happen that it is only one way communication, right? So you know, so basically, you know, this is kind of like a set of rules that you and your neighbor would follow if you have to talk to each other. Now let us say that your neighbor moves from your city and goes to another city, okay? But you still need to maintain the conversation, the connection that you used to have. So instead of co-location, your neighbor basically moves to another city. So you still need to maintain the the level of communication that you used to have. And maybe let us also assume, for increasing the complexity, let us assume that your neighbor gets a higher position in another company in another city, right? So how do you communicate? How do you communicate? So for that, you see, you need to have some new set of rules. One of which is that the simple air interface through which you were speaking, right? It may not be sufficient. You need to have certain levels of because the conversation that you are going to have, it's going to travel through media, which can be intercepted, right? So you need to have certain agreed upon encryption and decryption mechanisms so that the privacy of the communication is maintained. So what happens is that when you want to send a letter, you encrypt the message with certain mechanism which the intruder in between will not be able to understand, whereas the receiver at the receiving end will be able to decrypt the message using certain agreed upon keys, right? And then be able to understand what message you had sent, so that only you and your neighbor who is now living in another city would be able to understand each other, and anybody who gets a copy of the letter will not be able to understand, right? So like this is one example that I said. Like this, actually there are many other rules that both of you will have to follow in order for both of you to be able to communicate with one another. Now let us so this is basically where this layering concept basically comes into picture. So segregation of these different rules, right, into different layers is what is done in layering. So when basically two computers that they talk to each other, basically the layers, the corresponding layers basically have logical communication between them, right? I am going to illustrate this particular point very shortly, but before that I wanted to show you that I wanted to discuss a little bit further about the layers. So this communication that you are going to have between two different devices, this communication is basically segregated into these different layers, and every entity basically will be following this layering concept, meaning that only the device, only the layers, the layers, the peer-to-peer layers, basically they will be able to communicate. So it cannot happen that layer 1 of one device talks to layer 2 of another device, layer 2 of that device talks to layer 3 of another device. Directly it is not going to happen. So layer 1 of device 1 with layer 1 of device 2 with layer 1 of device 3. It is going to be like that, right? So they all, these layer 1, layer 1, layer 1 of these three devices, they basically understand the protocol that is followed. So this is one layer. Likewise, the protocol in layer 2, the protocol in layer 3, you can stack them up, right? So that stack is basically called the network model. So there are few different popular network models that have been proposed that we all use. So I'm going to talk more about these layers shortly. So try to understand what we have covered so far. So far we have covered in this semester, how physically, basically, physically how the different devices they can talk to each other, how the bits are going to be exchanged, how the bits are going to be framed, how the devices can talk to each other in an uninterrupted manner, how the sender device will not basically overwhelm the receiving device, so that they all maintain a certain flow of information between them. So all of these things and many others we have covered so far. So all of these are part of layer 1 and layer 2 of the network models that I am going to talk about. So in between, I wanted to introduce this concept of network modeling to you, so that you are able to appreciate now that in order to conquer the complexity that is in place when we are talking about an interconnection as big as the internet, when we are talking about this kind of complexity, how you are going to have this layer-to-layer communication facilitated so that they can all talk to each other. So far basically, let me tell you that we have talked about only the bottom two layers of the network models that will be followed. So this is called the physical layer and the data link layer. So I'm going to come to these different layers once more. But before that, let me give you a little bit of history. Back in 1970s, basically, the ISO organization, they developed an architecture for communication of different computers. So this particular, this particular architecture, the intent of this architecture was that it should it should serve as a reference model for building computers and interconnecting them with the network, right? So building the internetwork basically, right? That was the whole idea. So so that was the idea, and this organization ISO, they wanted it to be an open system kind of thing, which can be used by anybody in order to build the network of computers. So it's an open system interconnection reference model. In short, it is called the OSI model, which is quite popular, but basically it is kind of obsolete now. People have fallen back on something else, which is called the TCP/IP reference model, which also I am going to touch upon. Even though this OSI model, this ISO OSI model is kind of obsolete, but it serves from an academic point of view. It gives certain concepts which are important to understand for building computer networks. These are very important to understand. So we will now try to understand this OSI reference model from a purely academic point of view. Okay. So here in the OSI model, there are different layers, right? So OSI model, basically says that there are 7 layers that you can introduce in any device that can connect to the network, right? And so what are these 7 layers? I'm going to show you what those 7 layers are. But the thing is that each of these 7 layers, right? Layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, and layer 7. So each of these 7 layers, they have their own predefined set of functionalities which will have to be executed in the corresponding layers of the computers that want to be connected with each other and that want to talk to each other. Basically, so these layers will have to be followed. So so let us try to understand what these 7 layers are more specifically in the context of OSI. But mind you that even though this is kind of an obsolete model, this from a purely theoretical or academic point of view, this is very important. This is very fundamental, because everything that we refer to in the books actually will be referring to these different layers. So these different layers are the physical layer, the data link layer. So we read basically bottom up, right? So at the very bottom we have the physical layer, then we have the data link layer, then we have the network layer, then the transport layer, then the session layer, the presentation layer, and the application layer. Okay, so in the physical layer, basically we are talking about the physical medium like wired medium, wireless medium, etc. We are talking about bits, we are talking about signals, etc. So this is basically this physical layer. Data link layer, basically we are talking about medium access, framing, physical addressing, and so on. So these are basically data link layer. So many of these things, basically whatever we have covered so far, these belong to these bottom 2 layers, layer 1 which is physical and layer 2 which is data link. So far whatever we have covered belong to layer 1 and layer 2. So in the future classes, probably starting next week, we are going to talk about the higher layers. We are going to focus on network layer, where we are talking about how to how to have different logical unique addresses in the network, so that two computers who may not be co-located, who may be completely distantly separated on Earth, they can be addressed uniquely, and you can send data from one point to another. So IP address, so you probably, you must be all familiar with IP address, right? So IP addressing, which is a logical addressing scheme, basically belongs to this particular layer, right? It is called the network layer. So similarly, path determination from Kharagpur to San Francisco, I want to send a unit message, right? So whether it is going to go through some computers in Saudi Arabia and then through Europe somewhere and then to San Francisco, whether it is going to go that way, or from here, it is going to take another route, like, it is going to go through some computer in Singapore, from Singapore to Japan, Japan to San Francisco through some underwater cabling, so how it is going to go, right? What path it is going to take, right? So several paths can be there. So how it is going to, which path it is going to take, so that determination of the path, etc., this is part of the network layer. Then comes the transport layer. Transport layer basically says that, okay, you have established the path, two computers are now physically connected, you can send the packets basically from one to the other, but then how these packets are going to be, how the unit messages that are basically embedded in these packets, how they are going to be transmitted across these two computers. So basically, ultimately what happens when you are talking about two computers talking to each other, ultimately it's like one process with another process, right? So between the two different processes running on two different computers, basically this communication has to take place. So this process to process, that means the end-to-end communication, right? Facilitating that is basically done by the transport layer. Then you have the session layer, presentation layer, which are more like OSI specific and are basically not there explicitly in the TCP IP model, which is more commonly used, which I am going to talk about shortly. And then comes the application layer, which is this application layer, which basically talks about that two applications basically, so two different applications will also, they will have to talk to each other in a certain way. So you see that the entire set of rules basically that has to be followed has been broken or has been classified into these different layers, and these different layers, they can talk to each other. The adjacent layers basically, they can talk to each other, they pass the messages between them, and also so all these layers, these are basically embedded or these are basically what should I say, packaged. These are packaged into the different devices that are going to be part of the network, right? So let us, before proceeding further, let us have a quick look at the corresponding data that each of these layers they are going to send, right? So the physical layer, which we have talked about, physical layer basically communicates with the help of bits, right? So physical layer basically, two physical layers are going to exchange bits only. So if we are talking about the two data link layer of one computer with the data link layer of another computer, they are going to exchange something called frames, right? And this term frames also you are quite familiar, because we have talked about frame synchronization, we have talked about so a lot of framing errors and many concepts basically we have talked about in the context of frames, right? Because we have already covered data link layer. So these so this frame term, the term frame you have already come across. So this frame, the network layer basically, so it communicates with the help of something called the packets, transport layer with segments, and then the session, presentation, and the detail and the application layer, which you can also club them and call them as the application layer as it is done in the modern layering concepts basically. So they communicate with the help of the data, right? So basically bits, frames, packets, segments, and data, right? So these are the different PDUs as they are called, protocol data units, which will have to be exchanged between their peer layers, right? So what does it mean when I say that they will have to be they will have to be exchanged between their peer layers? Basically, what it means is that the data link layer of computer 1 should be able to talk to the data link layer of computer 2, and the PDU that they are going to exchange, the protocol data unit that they are going to exchange, is called the frames. So they are going to the data link layer of computer 1 sends frames to the data link layer of computer 2 and vice versa, right? It cannot happen that the data link layer of computer 1 sends some PDU to the transport layer of computer 2, No, that cannot happen directly. It cannot do, right? So basically, what happens? It's basically a logical connection. Actually, it's a logical connection. The physical connection is still through the wire, through the medium that connects these two computers. The physical connection is so, right? But the logical connection is basically between these different peers, right? Peer layers. So this is the concept of the logical connection. Okay. Achha. So now the question is that why do we need so many layers, right? So we need so many layers because computer communication is quite complex. There are so many tasks, so many algorithms, so many protocols that will have to be executed in a certain sequence, right? So in order to separate these different complex procedures, basically you need to have this layering, right? So here actually each layer will perform a certain task, and a particular layer, it's going to provide services to the adjacent layer. So what does it mean? That let us say that we focus on the data link layer. So the data link layer basically offers services to the physical layer which is underneath, and also the network layer which is above it, right? So every layer is going to provide services to its adjacent layers. Okay. So when I say adjacent layers, basically this communication is going to be physical, right? So directly you are going to talk to the adjacent layers, right? But when it is between the same layers of two different devices, there you need this logical connection. So let us now try to understand this concept of physical connection and the logical connection in little bit more detail. So now pictorially, let us look at these two different computers, computer A and computer B. Let us say that these two computers are basically are interconnected through some intermediate nodes. So computer A, computer B, in between you have some intermediate nodes. Let us call them as the routers. So you have device A connected to a particular router, that router connected to another router, and that router again connected to device B. Let us take a little bit more complex scenario than just directly connecting device A and device B together. So you see that, as I said, that any device that is internetwork will have to run these layers, right? So basically, you see these physical layer, data link layer, network layer, transport layer, session layer, presentation, and application. All these layers are going to the corresponding protocols, the corresponding software. So these are all going to be executed in computer A. Likewise, all these 7 layers are also going to be executed in computer B. But in between, you see these two intermediate nodes. So here we see that in this particular example, these intermediate nodes, they run not all the 7 layers, but only the 3 layers. The reason is that, as I said, that a router is a layer 3 device, right? A router is a layer 3 device. So in this particular example, I show that this computer is connected to a router which runs only 3 layers, right? Physical, data link, and network. So it doesn't have, the router is not going to run the transport layer, session layer, presentation, and application layers, because of the simple fact that the router does not, it's not concerned about transport layer processes or session layer, presentation, and application layer processes and the corresponding protocols. So it is going to be restricted to only the network layer, right? And correspondingly, if you have to run the network layer, you also need the services underneath, which are the data link layer and the physical layer. So you need, so a router is going to run not 7 layers, but only 3 layers, right? Physical, data link, and network. So likewise, physical, data link, and network. Now let us try to understand this physical communication and this layer to layer logical communication. So here you see that this physical layer will be talking to this physical. So you see this device A is connected to, is wired with the router over here. So you see that this physical connection basically shows it, and same thing from this node to this node, another physical connection, and then from this node to here, another physical connection. Acha. Now this is physically how the bits are going to travel, how the signals are going to travel between these different computers. But you try to understand that, as shown in this particular figure, this physical layer of device A is going to talk to the physical layer of intermediate node, this intermediate node, which is going to talk to the physical layer of this particular intermediate node, and the same thing on the other side. So it not happen that this physical layer of device A talks to the data link layer of this intermediate node right? That cannot happen. So you have to have, it is something like this, that you are part of an organization, right? Let us say that the director of IIT Kharagpur wants to send some letter to the director of IIT Kanpur, right? Let us just take an example. So normally what will happen, the letter basically is going to be sent to the secretary of the director. The secretary is going to put it in an envelope, and he or she is going to give it to the peon. The peon is going to take it and put it in the post office, and then the post office is going to carry it forward. And on the other side, when the letter is received, in that particular organization, IIT Kanpur, so basically it is not going to happen that the letter is going to be opened directly by the director, right? So typically it is going to be opened by the secretary. So that secretary is going to open it up and is going to give it to the director, if required, and then these two directors can indirectly basically talk to each other. So it's basically analogous to that only in a computer network also. And so what do we have over here? You see this physical layers, all these physical layers basically they talk to each other. Same thing, the data link layer talk to each other, network layer. So there has to be some protocol, right? So there has to be some protocol for this talking to take place, right? So that is where basically all these different protocols that we have talked about, and we are going to talk more. So all these protocols basically they will help this communication to happen. So this communication is stored is shown in a with a bidirectional arrow, right? So all these are shown with bidirectional arrow. So what does it mean? This bidirectional arrow means that the communication is going to be both ways, but this is also shown with a dashed line, right? Dashed arrow. So dashed means that it's not an actual communication, it's a logical communication, it's a logical connection that is going to be established between the corresponding PL layers of the two computers. Okay, is this clear? Any question? Okay, now, so layers 1, 2 and 3 are the physical layer, data link layer and network, and these are called the network support layers. Layer 4 is called the transport layer, and layers 5, 6 and 7 basically are the session layer, presentation layer and application layer, which are also called the user support layers. So you have network support layers, layers 1, 2 and 3, and user support layers, layers 5, 6 and 7, and in between you have this layer 4. Okay, in between you have this layer 4, which basically connects this network support layer with the user support layers. So you see that how this communication is going to take place. This is the physical wiring, let us say, the physical wiring. It can be wired or wireless, but for the sake of simplicity, I say that let us say that we are talking about a cable that is running between the two computers. Now you see that the PDU, every PDU, because they follow the peer-to-peer, they follow the same protocol, right? So every PDU, so they are going to have some header that is going to be put in them, right? So every PDU in a corresponding layer is going to have a header H1, for layer 2 H2, for layer 3 H3. So the header part, and this is the data part. So actual data is going to be here. So for example over here, right? So you have the header and this is basically the data. And over here it is also shown like the tail, basically this is the head and this is the tail. Tail is also shown over here, but so basically the whole idea is that you need some additional information, right, in the form of headers, etc., which basically will tell you number of different things. For example, if you are sending some PDU, it also stores the actual destination node for so where that particular message is going to be sent. So that is basically it's going to be inscribed into that particular header, right? So similarly, so it is also going to have, let us say, for error detection, the cyclic redundancy check code, right? CRC code is going to be inscribed in it. So like that, actually different headers they are going to have their different fields. So these different fields, they have their own different purposes, and so these different purposes basically are going to be served while executing the different protocols, right, which are going to run using them. So when tomorrow we are going to start talking about something called the Ethernet, which probably you have also heard about, but we are going to look at it from a more technical perspective. So there actually you are going to have a look at the different headers and their corresponding fields, right? So the different fields of their corresponding headers that are going to be used by the different protocols that are going to execute in the corresponding layers, right? So with this concept, let us now try to understand what these different layers are in little bit more depth, right? So physical layer, we have, as I said before, we have already understood. Physical layer is the bottommost layer of the OSI model, and it is responsible for the actual physical connection that takes place between the devices, the actual physical connection. That is why it is called the physical layer, right? So it basically it is concerned about the movement of the signals, the movement of the individual bits, the movement of the data from the actual data, the physical layer, the data or the signals from one computer to another computer. So that's basically the physical layer. So you see this physical layer, what it is going to do is it is going to take the data and the corresponding zeros and ones, it's going to send through the physical medium in this particular manner, right? So this from the data link layer, which is above the physical layer, the data is received, and this data is going to be sent through the physical layer from device A. It is going to be sent through the physical medium. It is going to be sent to the physical layer of device B, and finally the data are going to be extracted for use in the higher layers. So what are the different functions of the physical layer? So this is just a list of some of the ones that are there, and some of these actually you have already gone through in some of these previous lectures. So one is conversion of the bits to signals. This is something that we have already done. Bit synchronization also we have done. Managing the physical connection, bit rate control also partly we have done. Line configuration, physical topology we have done. Transmission mode, multiplexing we have gone through, and also something called switching. So these are some of these different functions of the physical layer. Then on top of the physical layer, we have the data link layer. The data link layer is primarily responsible for doing two things. One is the framing, which is basically putting together the different bits into different chunks, right? These chunks basically contains multiple bits, right? So these chunks are called the frames. So framing is basically the process of converting these different bits into these chunks, which is called the frame, right? So movement of frames from one node to another is basically done in the data link. So this is basically the frame. The conversion of the chunks of bits and putting them in the form of frame is called framing, and that is basically one of the primary functions of the data link layer, right? So this data link layer also has another very important functionality. It is called medium access control. And this is this medium access control that we talked about, all these different protocols like Aloha, slotted Aloha, CSMA-CD, CSMA-CA. These are basically these medium access control protocols that I am talking about, right? So that also we have gone through so far. And medium access control, that means who gets access to the medium when, that discipline basically is also a functionality of the data link layer. So let us quickly have a look at all these different functionalities. Framing, that means dividing the data that is received from the network layer into different chunks, which are called the frames. Then physical addressing, adding a header to the frame to define the physical address of the source and the destination address. Remember that physical addresses are basically hard inscribed into these messages, because these physical addresses are these are unique addresses, right? These are unique addresses. These physical addresses are whenever the corresponding network interface card is purchased from the vendor, these unique physical addresses are basically stored in them. So this, how you are going to do this physical addressing, is also part of it, but actually we have not covered physical addressing so far. We are going to talk about physical addressing more when we talk about Ethernet in further detail. So physical address is very important, and it is also part of this data link layer. Then comes the flow control. In flow control, actually we are talking about how to make this sender and the receiver synchronize their different speeds of transmission and reception, so that one doesn't overwhelm the other. Error control also we have gone through. Flow control, we have seen many different mechanisms of flow control, stop and wait, right, sliding window. These are some of these different mechanisms of flow control. Same likewise also error control mechanisms, error detection, error correction. Error correction we have not gone through, but detection of the errors, etc., and controlling errors also, these are part, these are actually we have seen. So stop and wait can also, for example, do error control to some extent, right? So like that, actually indirectly also you can do error control. So this error control we have seen. Then the feedback, basically after transmitting the frames, the system basically waits for the feedback, some kind of an acknowledgement. So that is basically also part of the data link layer. Okay. So you see this communication. If you look at the communication, basically, if you take any of these layers, for example, this network layer, which is on top of the data link layer, there actually you see this the data is received from the layer above, which is the L4. So this L4 data is basically the transport layer data. So this network layer takes the transport layer data, and then it puts it in the form of a packet, gives it an address kind of thing, which is called the header, right? And then this entire PDU is sent to the data link layer, right, along with the header, right? So you see the data part and the header part in the network layer put together to form the data of the data link layer, right? And this data in the data link layer will also again have its own different header, and then again it is going to be put together and sent to the layer below. So this is how basically, so this is how the sender side network layer is going to look like. And in the receiver side, basically, so what is going to happen from the data link layer in the receiver side, and the L3 data is going to be pulled by the network layer, and this network layer is going to remove the header and then use this packet which actually contains the data, and that is going to be sent to the higher layer above, which is the transport layer, so L4 data, right? So this is how this communication between these different layers takes place. Okay, so this is basically this network layer to network layer communication. So what are the functions of the network layer? It's basically responsible for the source to destination delivery of the packets across multiple networks. I mean, so this is something that I was telling you, that example that from Kharagpur to San Francisco, how the data is going to travel. There are multiple different paths that are possible. So how which path it is going to take, right? So determining that basically is done by the network layer. So this is one thing. Second thing is so basically this addressing part. So this is also called routing, right? This is also called routing. Forwarding and routing are basically part of this network layer, and then comes the logical addressing, right? So logical addressing means this IP address, etc. This is also part of the network layer. So transport layer, here actually this process to process end-to-end communication is going to be facilitated. So between the source process in the source computer to the destination process in the destination computer, running two different processes, these two processes communicating with each other, running different applications, etc. So that's basically part of this transport layer. How you are going to facilitate that, right? So that's what the transport layer does. Transport layer basically can offer two types of services. One is called the connection oriented service. The other one is called the connection less service. In connection oriented, basically we are also talking about receiving some kind of feedback, which is the acknowledgement back to the source. So after the packet or the group of packets are received by the destination, this destination node is going to send certain acknowledgement or a group of acknowledgements, right, which is going to indicate that the message is successfully received. So this connection oriented transmission basically facilitates this kind of mechanism with the help of acknowledgement transmission from the recipient to the back to the sender. Connectionless transmission, in this type of transmission, the receiver does not acknowledge the receipt of the paper. So it's the receipt of the packet. So basically, once it is sent, it's a best effort kind of mechanism through which the packet is going to be sent through the network. If it is received at the receiver end, that is fine. If it is not received, so because there is no acknowledgement mechanism, if it is not received, so you do not have any other way to send it once again, right? So of course, there are certain improvements of this connectionless mechanism also, but basically they both have their own different advantages and disadvantages, and depending on which application layer protocol you are running, you need to take help of either the transport layer connection oriented transmission or the transport layer connectionless transmission. So either of these you are going to use. So TCP basically, which you have been working on in the lab, basically is a connection oriented protocol, Whereas UDP, which also you have come across, that's a connectionless protocol. So actually in the lab, most of these exercises that you have been doing, basically it's these are actually part of the transport layer, right? So these are all part of the transport layer. Okay, of course, so whenever we are talking about some application layer protocols like FTP, etc. And so those are application layer, but they take the services of the underlying transport layer, whether it is TCP or whether it is UDP. Right. So let me just quickly go through the functions of the transport layer: segmentation and reassembly, which means they're dividing the message from the session layer into segments and numbering them to make a sequence for reassembly at the receiving side. Service point addressing, which is basically to ensure that the message is delivered to the correct process in the destination machine. Error control makes sure that the entire message arrives without errors. Otherwise it has to be retransmitted, and flow control basically makes sure that the sender and the receiver communicate at a rate that they both can handle together. Session layer and presentation layer I'm not going to talk about further, but session layer is responsible for the beginning, maintaining and ending of the communication between two devices. This is also called the session, right? So maintaining this session, initiating the session, maintaining the session and tearing down of the session between two different computers, that is basically done as part of the functionality of the session layer. So I'm not going to go through it in further detail. But the presentation layer basically is on top of the session layer, and here actually we are concerned about the presentation issues. For example, the syntax, the semantics of the data that are going to be exchanged between the two systems, right? So that's the presentation layer, and then comes the application layer. The application layer basically talks about all these different applications, the directory services, X500, X400. Email protocols, file transfer protocols. So all these are basically part of the application layer. Okay. So here is the summary of all these different OSI layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And their corresponding main functionalities are also shown pictorially for you. And once I share the slides with you, this will help you to remember the different main functionalities, and remember that you really need to understand the different functionalities of these different layers and the sequence in which these layers they fit to each other, because this sequence is very important. You need to really remember and really understand that how this communication between these 7 layers are going to take place, and you need to remember the names of all these 7 layers also, right? So OSI is a reference architecture that's very interesting. That's very important. Theoretically, it is very important. But the internet, the present day internet that we all use, that uses another reference architecture, which is called the TCP/IP reference architecture. TCP and IP are two different protocols that are the main protocols of this particular model. And this model was initially, it was used by the US ARPANET project, right? So in the TCP/IP protocol suite, here actually we have 4 layers traditionally. So what? So basically 4 layers on top of the bare basic underlying hardware. So on the underlying hardware, you have these 4 layers which are going to run. That was the traditional TCP/IP protocol suite. So what are these different layers? So we have the host to network layer, internet layer, transport layer, and application layer. This is what traditionally used to, so it was conventionally it was proposed this way. However, at present, things have, with the influence of OSI model and so on, basically, things have been simplified. So in the TCP/IP also, we are talking about these layers now, right? So we are talking about the physical layer, the data link layer, the network layer, transport layer, and application layer, right? So here you notice that the session layer and the presentation layer, as it used to be there in the traditional OSI model, those have vanished, right? So these have been subsumed within the application layer. These have been subsumed within the application layer. So physical layer, data link layer, network layer, transport layer, and application layer. This is basically the simplified view of the TCP/IP model, and the corresponding corresponding addresses are also shown over here. So at the physical layer and the data link layer, we talk about physical addresses. In the network layer, we talk about logical addresses. In the transport layer, we talk about port addresses, and in the application layer, we talk about specific addresses, right? So let us try to understand these different and addresses in a little bit more detail. So these are the 4 classes of addresses. Physical address. So physical address basically is a hard-coded address, which is there in the network interface card, right? So when this network interface card is manufactured by the vendor, at that time a physical address is put in, and it's a 6-byte. That means 48 bit, right? 6 byte is 48 bit. So this network address, this physical address is 48 bits long, right? Then you have the logical address, which is used in the network layer. So here actually it's a 32-bit address, right? IP addresses are 32-bit addresses. So the IP address basically is the logical addressing mechanism, and that is used in the network layer, right? Then you have the port address, which is used in the transport layer, and your assignments in the lab, you are using this port a lot, right? So this is basically because that your assignments are in the transport layer, right? So all these assignments from the first lab assignment, these are part of the transport layer. Although we don't refer to transport layer, the way we have been giving you the assignment, basically, even if you do not understand what is transport layer, with the basic philosophy of TCP and UDP that we have covered in the first few lectures, you are able to understand those, right? So there anyway you have used port addresses, and you understand that what is the meaning of this port address. Basically, these application specific processes that are executing, the port number, the port address, basically this port number is the port address. This port number basically can help you to identify that corresponding logical that corresponding process that is going to either send or receive the data. So port addresses are part of the transport layer. And then application specific addresses, for example, the URL, right? So any URL is an application specific address. The email address is also an application specific address, like that, so you have this application specific addresses. So that's all about this this reference architecture, TCP model, and TCP/IP referential architecture is used heavily in in the modern internet. And OSI is more from a theoretical point of view. There is a reason actually. OSI model was it started with the aim of making it more more global and standardized. However, OSI model did not succeed, right? Rather TCP/IP it became more popular, right? So TCP/IP became more popular, and in the internet, basically remember that we are using the TCP/IP referential architecture. That's all for today. So any quick question? So anyway, we are going to meet in the lab today. Actually, it's going to be a joint lab, Professor Aurobindo Gupta and me. So together, actually, this lab is going to be taken together. So he is going to cover a couple of things which you should also know. So please make sure that you attend the lab today. Although basically the previous assignment is going to be continued, but few new concepts are also going to be covered. Okay, so that's all for today. Thank you. Bye bye.